Great. Well, thank you very much for the introduction, and it's wonderful to see so many of you here today. So thank you very much for turning up to hear a few things about what we've been doing at Fisher Farms. So for the first thing we're going to do is I'm going to show a quick video of our Farm 2, and Farm 2 is about 12 minutes from where we are now, so it's really, really close, and it'd be a good idea at the beginning, just for everybody to have an understanding what a sort of vertical farm actually looks like at this a particular scale. So this photograph you have here is actually Farm 2, and yet again we're going to see a little video about that. But just in terms of people here, has anybody been to a vertical farm here in the room? Is anybody aware? So 1, 2, 3 people in vertical farms. Where vertical farms, just out of curiosity, where have you? Oh, well, okay, apart from our one, has anybody been to another vertical farm which isn't? So we're okay, fantastic. Fantastic. Okay, so some of us here have been to vertical farm before, so it's really kind of useful to be aware of that as well. Okay, so we're just going to kick off with this little video. Let's sort of assuming that it works okay. So this is the sort of original site. Essentially, we're sort of stripping the land, and then we're putting this steel portal frame building, which has a long corridor and a big processing building on the side. And what you're seeing down here coming on the edges is our growing tunnels. And there are 20 growing tunnels in total. So they basically get built. This area here is the main process building. This is this long central corridor. It's a 100-meter long corridor. This is one of the growing tunnels, and all the sort of the racking and scaffolding system being put in place with all the various different lights which are being put up. This is where all of our robots, our automated storage retrieval units were assembled and put together. And at the end, you have a sort of a pretty large building, as I said, with these 10 growing tunnels on the left-hand side and on the right-hand side. Each tunnel has 2 big yellow doors inside it, and inside that there's these big racks where you have the product which is being grown. And then you have these automated storage retrieval units which go along, grab the trays out of the tunnel, and then they go down 100-meter long corridor to the end of the corridor, where we can sort of monitor things, go through a harvesting system, and then the product, the sort of next generation products are seeded on various different substrates, which you can see here. The plants eventually grow, and then, hey presto, you've got some short leafy green things coming out at the end of that. So that is really fast how a large vertical farm actually looks like. So I'm just going to move on to the next one. So my background is in clean energy infrastructure. So I've been involved in wind projects, solar projects, wave energy, tidal energy, carbon capture as the chairman of a carbon capture company, battery storage, grid, dynamic load software, big biomass projects, energy efficiency for steel facilities, for coal mines, a whole range of different types of infrastructures, coal mine methane recovery, whole range of different infrastructure which has been involved in the renewable space. And one thing which became very clear to me as I was doing my work is that climate change really is a thing. And for 25, 30 years or so, there was a sort of a level of denial that climate change was actually happening. And so I don't think we did enough early enough to resolve and deal with some of the issues which we're facing now. And prior to setting up Fisher Farms, I had a previous company called Lumicity, which was doing solar projects and wind projects. But we were also involved in a very, very large project with Bernard Matthews, which yet again, for most of you, you will know that Bernard Matthews is just around the corner. It's a really big employer in Norfolk. And we installed in my previous company biomass heating systems into the chicken turkey sheds to provide the heating for the birds. And that got me really interested in this crossover between food and energy. And also started to make me think about, if we are living in a world where climate change is actually a real thing, how do we actually feed the world when we've got underlying problems in terms of water, lack of water, problems in terms of quality soil and lack of good soil, and a lot of our good soil has been built over to build new cities and stuff like that. So you've got this supply side problem, but also you have increased population, increased middle class population who want to have salads and salmon and go on a holiday and go skiing and have air travel and have TVs and all these kinds of material things. How do we have all of those things together where the demand is going up, supply is going down, and we've got climate change? And how does that work? And so Fisher Farms was set up to try to address this issue of essentially, how do we feed the world without trashing the planet at the same time? Because if we can solve that problem, then we are living in a world of huge amount of hope. So all these issues of, we don't have enough food, we don't have enough materials, climate change is happening. We can deal with a huge part of that problem by actually doing something about it. So set up Fisher Farms. We originally started off in a shipping container, and then we built our first farm, which is just north of Birmingham, near Lichfield, and then we built Farm 2, which is the one which you just saw a few minutes ago. So we have split the activities, what Fisher Farms does, into 3 phases. And these phases are really important for you guys here, specifically for you guys here. And we have phase 1, phase 2, and phase 3. Now, phase 1 is what most vertical farms do today. So most vertical farms grow short leafy green things, salads and herbs. Now, you are not going to feed the world by giving them a salad. Okay, it's not going to happen. So phase 1 crops are important because we can make money out of phase 1 crops today, and that allows us to have the money to then invest in our phase 2 crops, which then gives us the money to invest in the phase 3 crops. And one thing which is really important for, yet again, all of you here, is that there are the sort of the climate movement, the environmental movement, has 2 parts of it, and both parts are very important. One part is the advocating part. It's the part where people say, climate change is a problem, we got to do something about it, and you run around and you do protests and marches and all this kind of stuff. That's the advocacy part, and is also linked to the charity part of it. But fundamentally, if you want to actually do something about these problems, you have to create companies, and these companies have to make money, have to be profitable, so that they can then reinvest and do more good stuff, to be able to reinvest and do more good stuff, and reinvest and do more good stuff. So the sort of the profitability side, the capitalist side of this process is what is getting us out of this problem. So it's really important to have those 2 parts. You cannot have, the work which has been done in terms of creating these capitalist companies, which actually make money and do good things, like the companies which are involved in solar. Solar today in the European Union represents 23% of all the kilowatt hours generated of electricity in 2022. So nearly a quarter. 20 years ago, it was close to 0%. So you can see how over a 20-year period of time, you've gone from solar and wind energy producing almost no electricity that is worth talking about to being 23%. And that happened because companies were created to actually build these things, to develop the technologies and stuff like that. And this is what has to happen as well for the vertical farming sector. So phase one crops, short leafy green things, they taste great, they're absolutely fantastic. These are really, really high quality products. There's a whole good reason why customers like them and love them, but fundamentally, you're not going to feed the world. Phase two crops are more useful. Phase two crops are what we refer to as fruiters. So they're your strawberries, your blueberries, your raspberries, mushrooms. They have more calories, they have more nutrition, they're more useful, but yet again, you're not going to feed the world by giving somebody a strawberry. You need to have something more than that as well. And that brings us to our phase three crops. And the phase three crops, what we're focusing on are wheat and rice. And wheat and rice represent 52% of all human calorie intake, 52% from those two crops. These are really important crops for us to get right. Pea and soy are fantastic protein substitutes and for in a protein substitute for meat. So yet again, from an environmental perspective, having more peas, having more soy-based diet really, really helps in terms of the impact that climate change, that agriculture has on climate change. And that is fundamentally where we want to end up at Fischer Farms. The problem is, phase two crops, we can't make money. Phase three crops, we really can't make money. We know we can grow them, so it's not a growth problem. All these are crops which can be grown in vertical farm structures, but we can't make money out of them today. And so the question is, why can we make money out of the short leafy green things when we can't for strawberries and we can't for rice and wheat and soy and peas? And the fundamental reason why is that short leafy green things have a certain series of characteristics which actually make them fantastic for vertical farming today. They are very, very short life product, so they'll last a few days, so you're not getting massive international transport of crops going from one part of the world to another. They are very high value product, and so we can actually pay the money which we get from them is sufficient to pay for all of our costs. But fundamentally in the vertical farm, there are two core costs which we have to worry about. The first cost is electricity. So anything which we can do to make the cost of electricity lower and anything which we can do to make our systems more efficient reduces that cost of electricity. Now, the good news, the really good news for us all here and great news for me is that the cost of renewables, of solar and wind combined with batteries is getting cheaper and cheaper and cheaper every year. And so to give you an idea, for example, on batteries and why batteries are important is because we can have a solar farm, which is great during the daylight, but at nighttime, not so good. So you need to have something to be able to store that electricity. Battery costs have gone from about $10,000 a kilowatt hour 10 years ago to China prices last year of $265 a kilowatt hour to this year, $65 a kilowatt hour. 10,000, 265, 65. That is just an incredible improvement in terms of the price. You're seeing that with solar. You're seeing that with wind. So you're seeing systems which were previously very expensive becoming significantly more affordable compared to where they were. And that drives down the cost of electricity. That is a fantastic part. The other part is efficiency, just overall efficiency, efficiency of our lights, efficiency of our HVAC system. All of those things are critical to that. The second thing which we need is to significantly reduce the cost of labor. And the more automation that we have, the lower that component is. And it's also important because when humans come into our buildings, they are the leading vector of disease in a farm. So basically, the fewer people you have in there, the better. In the same way that you'll have large chip fabs, in Taiwan. You just don't want anybody in these chip fabs because, a hair floating around the air could just ruin all the equipment. A flake of dandruff could ruin all the equipment. A lot of organizations, a lot of businesses are really, really focusing on making these clean environments. Clean environments are very, very important as part of that overall structure as well. So I talked about the core growing crops. And one of the things which, we're hoping that you guys start to get involved in is trying to think about how you can make those growing crops have high yields and grow in a way which is more effective for vertical farms. But in addition to that, there are a whole series of other things which you can grow in a vertical farm structure. And what you've got to think about vertical farming is that it's basically a growing platform. It's a system which allows you to grow certain things. There's certain things which we could theoretically grow, but we can't really imagine ourselves wanting to grow. So we could grow potatoes. We could grow carrots. The issue with that is that you need depth for the roots and you need height for the canopy. So the amount of space which you need of the vertical space of the vertical farm gets worse if you have big root systems or big tree canopy systems. We don't think we're going to be growing trees, as in apple plants or lemons or oranges or walnuts or avocados. We don't think all those kind of products are very, very suitable for the vertical farming space either. Theoretically, we could grow, but it doesn't really make sense in terms of the type of design structure which we have. But there are a lot of other systems like plant-based pharma, nutraceuticals, cosmetics, which are all need plants which are actually quite compatible with what we can grow in a vertical farm type of structure. So if you look at sort of the vertical farming, one of the key areas which we sort of talked about a little earlier was the land. The lack of, there's an issue with land, there's an issue with water around the world. And some sort of useful stats for people to sort of walk away with when they go home. About 25% of all the food that we eat today comes from underground aquifer-based water systems. And those water systems are under significant stress. And in most of those water systems will have run out in about 20 years' time. Just think about that for a second. 25% of our food comes from places where they have water systems, and in 20 years' time, that water will no longer be available. This is a big issue. This is not like a little issue. This is a real big problem. We use about 5% of the water of a conventional farm. Massive, massive improvement. Our water just goes round and round and round. Our nutrients go round and round and round, which is one of the reasons why we use about 1/8 of the fertilizer that you need in a conventional farm, because our fertilizer just goes around and round and round. We don't have the nitrates and the phosphate runoff that you get in conventional farming systems, because our water just goes round and round and round. So there are certain benefits that you can get from water from vertical farming, which you can't get in a conventional farming system. In terms of land, depending on the type of crop, we get significantly more yield per acre of land and lousy land compared to conventional farm. So some of our short leafy greens, we are on a 1 to 250 ratio. For things like wheat, we're about at a 1 to 35, 1 to 40 ratio. And the reason why is actually relatively simple. It's because we get more plantings in a season. So instead of having certain crops, you can only plant one crop in a whole year. We can get multiple harvests of that same thing. And we have the benefit of the height. So we can just have multiple levels, and the more levels you have more growing surface area on an underlying piece of land underneath that as well. So we do very well on the land use and the water use. A lot of the other sides are for the sort of short leafy products, extended shelf life, pesticide free, product washing avoided, for a lot of the people in the food industry, one of the big issues that they have to face is that plants grow in the real world, and the real world has weather, and sometimes it's rainy, sometimes it's snowing, sometimes it's hailing, sometimes it's dry, sometimes it's windy, sometimes it's a mixture of all of those in a day. And so for a conventional farmer, it's very difficult to actually, really hard in a world where climate change is really, the change part is chaos. It's the chaotic, is the part where people don't really know whether you're supposed to be growing a drought-resistant crop, or are you supposed to be growing a flood-resistant crop, or are you supposed to be growing a drought and flood-resistant crop? It's very difficult for farmers to actually determine what they should be putting in the ground, because every day, every year, things seem to change. And people in the food industry, come to us at Fisher Farms and say, what places where they used to have really, really regular harvest, where we knew what we're going to getting, every year there's some kind of 1 in 100-year event, a 1 in 1,000-year event. And it's very difficult for them to actually manage these very, very complicated supply chains. Whereas we're in a situation where it can be snowing outside, raining outside, hailing outside, windy outside, hot outside, cold outside. It doesn't matter. We are able to control our environment 365 days a year. And the way to think about it is that we are taking a regular seed and we are putting it in heaven, seed heaven. We are giving that seed every single thing that seed can have in order to be the perfect plant that it can be. So that is essentially what we're doing by providing the environment of a vertical farm structure. One of the critical factors of complex systems is how do you get them to scale? Because you can say, well, that's great. The video I showed you earlier, that building is a 4-acre building. It's a 4-acre building, and it produces about the same amount of food as roughly 1,000 acres worth of British farmland. The 4 acres to about 1,000 acres, depending on the product. Some will be less than 1,000, some a lot less than 1,000, but your sort of maximum level is about 4 acres to about 1,000 acres. One of the key things about vertical farming is how do we scale it? How do we get to that scale which we need? A lot of that's to do with cost. How do we drive down the costs of the overall systems? How do we drive down the cost or benefit from the cost reduction in terms of electricity? How do we benefit from things like robotics? Humanoid robots, a lot of you guys here may be sort of more increasingly aware of what has been going on in the marriage of large language models controlling humanoid robots with really, really good actuators, which didn't exist 18 months ago, 24 months ago. There's a whole new set of industries which are coming out there. But scaling is a massively important part of the things which we need to think about for that. So some questions for you guys to mull over, once you've left this room as well, is, what kind of crops would be good crops for vertical farming systems? What would be, when you're sort of thinking about what the research which you're doing, you think to yourself, okay, I can see that this is the future of farming. I can see that this growing platform allows us access to certain things which we were never able to do before. And this is one of the really great things about platform technologies. They change the way things are done. So when you're, your current generation, you're thinking, okay, I'm going into the field and I'm worrying about this issue or that issue or that issue or that issue. And people become experts in understanding how plants and seeds interact with certain types of environmental parameters. But the real question is, if you have a system, a vertical farming system, which gives you a huge amount of control over the environment, what kind of things would you do to make use of that type of platform? Because those activities and those thought processes are the processes which are going to get you research grants. When you're sort of going out there and thinking, okay, what am I going to do next? What's my next project? Okay, I'm going to try to do something on a vertical farming basis, and I'm going to do something special and exciting with that particular plant. Or how do we actually go on a more grandiose side? And again, not just what we're doing on a sort of research grant basis, but what else can we do which actually is heavily commercialized in terms of the crops which you're doing there. One of the things which I sort of talked about earlier is the energy side, and you may recall that my background is in the energy sector, clean energy sector. But I started off my life doing large-scale power stations, conventional power stations, big coal power stations, big gas-fired power stations. And the world is actually changing at the moment at a breakneck speed. And sometimes when you're in the midst of the flow of these changes, you don't actually really realize how significant some of these changes are. But what used to be is that you would have three very separate systems. You'd have a system for generating electricity, you'd have a system for transport, moving people around, and you'd have a system for food. And they didn't really have a lot to do with each other. They were quite separate systems. But what's starting to happen now is that these three systems are actually starting to merge into one mega system, which all benefit from each other. So it used to be a big 500 megawatt to 2,000 megawatt power station, coal power station, gas-fired power station. And there were big centralized units, and they send the electricity from high voltage lines to medium voltage lines to the low voltage networks and into the sort of the villages as far as you could go, like a big heart going all the way down to capillaries. But what we're starting to see now with renewables is huge systems which are actually built on the edges, on using solar, using wind, using batteries, which are driving electricity into the core. The transportation system also used to be predominantly oil-based, so diesel cars, petrol cars, kerosene for aviation. And now, yet again, you're seeing electric vehicles with battery packs. And the battery packs that you're using for electric vehicles are also the same battery packs which you're seeing in the energy sector, the electricity sector, for storage of that power. So those are all reinforcing off each other. So those two systems, mobility and core electricity sector, are merging into each other. And that is one of the reasons why the price of batteries is dropping so rapidly, because you've got innovation in terms of what's going on in the car sector being able to be scaled at huge volumes, which can then be translated into the conventional energy sector. The food sector is going through the same process as well with vertical farming, because vertical farming also requires electricity for the lights and the HVAC systems. So massively benefiting from the electricity from wind and from solar and the battery storage side. So these three sectors are starting to move together, and things like advanced robotics, yet again, are actually moving around and making all of those systems much more efficient. And what's interesting is that if you add the transport sector, and if you add the mobility, the mobility sector and the electricity sector and the agricultural sector together, they represent about 75% of greenhouse gas emissions. And so the fact that these three systems are now actually converging on each other means that the speed at which it is possible to decarbonize all three of these major systems gets faster and faster and faster every year. And this is really exciting. I mean, this is fantastic, really hopeful in terms of where we are going as a people in the planet. I'm going to skip this slide because I think I've talked a lot about it. The plants, we've hinted at some of these things as well. We generally like short. Anything which has a fast growth cycle basically means we can actually do more harvest per year. We generally like high value crops, but clearly rice and wheat are not high value crops, not remotely. Ideally, low light. Low light means less energy required. Root disease resistance is a major benefit to us. Disease, how do we manage disease on large scale systems? A very, very important part for us. But there's a lot of work which you guys can do as well. So rice and wheat. In a field, you want to have a plant which is sufficiently tall so that it actually can deal with localized flooding, any kind of other sort of environmental impacts. But in a vertical farm, you would actually really want a pretty short plant with a really, really large cob, and packed. And that type of plant in the field, with a strong wind, would bam, instantly get knocked over and never recover. But in a vertical farm system, you can control the speed of the wind. And you can say, okay, I need a plant which can be resistant to this amount of airflow flowing through it. I don't have to worry about the flooding situation. I don't have to worry about all those kinds of things. So changing the actual parameters of the plant to make it much more suitable for a vertical farm system is something else which is really, really important that we should be thinking about doing. Ideally, we will have no soil and we will have no growing media at all. And the reason for this is that it adds cost, it adds complexity, it adds variability and risk associated with it. So anything which we can do to have, so we've got some of our plants which are growing at the moment where we're not using any substrate at all. And that's brilliant. It's like no substrate means no cost, no risk associated with bringing in sort of foreign materials and things like that into the system. Ideally, we will be having crops which can deal with multiple harvests. And the reason why is because a lot of the plants which we have in our system are exponential in growth towards the final stage. So you'll have, the first few days, there's really almost nothing to see, and then almost a little bit more, and then the final 2 or 3 days, there's like that. Not all the plants. Some of the plants have a much more linear growth, but a lot of our plants have a much faster, almost exponential growth rate towards the end. So plants which have those kind of characteristics are also fantastic. Some of the plants which we could be growing need pollination. And so how do you deal with that in a closed environment like a vertical farm? Big questions. What do you do about that? So in terms of how we can collaborate together, and the reason why here, just sort of to make sure you understand, is that our view is that what you guys are doing should be directly relevant to what we are doing. So you guys should be thinking about, could we do this experiment with Fischer Farms? Could we do this? Could you provide us some subsystems that we could put here, whereby we could do certain activities here, which would then translate into what it would be like in a large farm type system? Really important question. So if this is, yet again, if this is the future of farming, how do you get your heads around and think, okay, what do I need to do to experiment with these kinds of systems to be able to grow them at a large scale? Vertical farming is a new industry. You can't just pick vertical farmers. No, we don't get batches of CVs where people, vertical farm experience, oh yes, more vertical farm. We go through CVs like, nope, none of them. Nobody has vertical farming experience. And this is really exciting for everybody here because you guys get to be the pioneers of this growing sector. And so what we want is to be able to support bachelor's, master's, PhD, postdoc students working on the kind of activity related to vertical farming, get them to come to work at Fischer Farms, do specific types of projects, do some trials. How do we get you guys involved and actually into our systems? And that then gives you new ideas about how to do things. It's fantastic for us, but it's also fantastic for your own personal career development as well. There are lots of people who do regular farming, who have access to, and we've been doing it for 10,000 years. But you're in a cohort now where you are at the beginning of the next 10,000 years. So think about the skills which you guys will have over everybody else by working in a vertical farming type of system. Are there projects which you're currently working on in the lab today where you go, I could tweak this, I could do something else, and it could become applicable for a vertical farming setup and scenario? So it's not, I'm going to chuck everything I've been doing away for the last year, 2 years, 10 years, 20 years, 30 years of your research life or whatever it might be. But it's like, okay, this is what's happening now. I could do this, and it's now a vertical farming project, and I get to have a whole new set of research and questions which I could ask, and then answers which I can look for by going and moving down this particular approach. And one of the things which we are starting to get good at, and we brought on new people who allow us to be good at this, is be much, much more data focused. But we are really, really at the base level of good data in our systems. So people who go, I love R, give me some data, I'm going to shove it through the system, I'm going to get excited about doing that. The Python coders out here, yes, we have stuff which you guys could be doing at Fisher Farms, understanding data, understanding how your systems work and how they could work with us. There are huge amount of stuff which is happening now with large language models. How can you get your LLM of your preferred variation to work on the sort of data type sets which we have and the data sets which you have to actually work together? So lots of things which we can do. And with that, can I have questions? Do I have time for questions? Have I blown my budget? I don't know where I am.
Thank you very much. I'll do the running. Do we have questions in the room? All the way up. Introduce yourself.
Yes, I will. Thank you for the great talk. My name is Eleftheria Trampari, and I work at the Quadram Institute, just across the road. Can you hear me? I think, yes. Anyway, what are your thoughts on microbial interventions? And I will add some context into this. So plants, obviously in nature, have co-evolved with microbes. And specific microbes have even the ability to protect those from diseases. But also my research focuses on the microbiome and how it also protects the plants from human pathogens, such as foodborne diseases. So what are your thoughts being in this industry? Would you consider microbial interventions on those closed, sterile systems if those had benefits for improving for bacteria?
Okay. I think I'm going to ask Dr. Phil to actually answer some of those questions directly. I think generally, I think the answer is yes. At the moment, we're trying to have a sterile environment. But there will come a point where ultimately, I think we will get systems where we're comfortable with certain types of co-evolved organisms to live in our system. But Dr. Phil, I really want to answer that.
So really good question and quite poignant. So we try to grow our crops so they're ready to eat.
there's a big difference between ready to eat and sterile. Our systems are not sterile. They do have bacteria in. From a food safety point of view, what we have to do is test what microbes are in the water, check there's no plant pathogens. When we've looked at adding microbes into the system before, what we've found is that some of them are in the same family as plant pathogens. And so the tests that we do for food safety suddenly go off the charts in red emails and people panicking because we don't have enough data or a quick enough test to identify them. So yes, we're interested in all of those things. The more microbes we can get in the system, the more stable it will be, the less chance of pathogens there actually are. But some of that more detailed, what is actually in the system information is still required and is a bit of a black box. So,
Excellent question and brilliantly answered.
Yeah. Can you? Is it working? Yeah. Anthony Dodd from the John Innes Centre. Do you know in your kind of growing system, which maybe is hydroponics, do you know what the quantity of carbon is that's released by the plants into the growing media? Because, you know, in experiments, we know that plants can release up to about 25% of their captured carbon as root exudates. And you know, in your growing system, probably that's lost, right? And that's 25% of the growth potential of the plants. So I'm wondering if you've ever estimated how much of...
So we have not done that calculation. I don't know, Doctor, have you done it in previous existence?
no, but it's almost certainly there if we take the microbes involved.
Yeah. Yeah, because, you know, some labs around the world are trying to increase root exudation for the purpose of carbon capture into soil, but it may be what a vertical farm needs is the opposite of that.
Yeah, I mean, one of the questions, what do we do with our roots? And what do we do, you know, with the crop afterwards? And, you know, there are basically several routes, options. One is to plow it into fields as a bioenhancer. It's got, you know, it will have some kind of substrate with it. It's packed full of nutrients and it's got the biomass associated with it. So that's one really good way of dealing with it. The other one is using anaerobic digesters to create some kind of biogas associated with it. So there are different options about what we do after that process.
But it's not the roots I'm talking about. It's what's coming out of the roots and going into the growth media. Right, exactly. So, you know, if you get rid of the growing medium, the liquid, you're getting rid of the carbon.
Yeah.
Exactly, that will destroy all of those compounds. So if there was a way to suck them out, we could do something with them. But if we could get something that doesn't produce exudates and still be healthy, then we won't have as many microbes in the system. So it would all work in potentially favour.
Yeah, I'm interested in how you develop a nutrient growing solution. And are there any regulations around it? What can and can't be in it? Permitted levels, anything like that?
So the ones which historically have been used in hydroponic systems. And so, you know, every single glass house growing tomatoes or bell peppers or strawberries or things like that are using a AB mixture, which is put together on site and then released into that. And so this yet again, I think is a really good area of development which needs to be done because you know, there are certain companies out there who are getting better at analyzing what nutrients you have in the water at any moment in time in real live data. Going to a lab and getting the data sent back a week later is not helpful at all. You know, so we really looking for something where we can get absolute live data, and then we can actually see what are the plants actually taking up. Because if we put, you know, 100 units in, and 40 of those things have been taken out, well, we know that, 60 is left and they'll really like the 40 parts. So do we need to be more the 40 or what's the sort of the rate? So I think understanding the nutrient mix, how do we analyze it? How do we get data on that? I know Dr. Phil, when I was just, chatting with earlier, he's looking at all our systems, looking at what all the macro nutrients are, what are the micronutrients are in the water at any moment in time, and also where they are on the crop cycle, because typically if you've got too much in the early phases, you damage the plant. The roots just are too weak. But then if you have the same amount towards the end of the cycle, then the plants actually can't absorb enough macro and micronutrients in order to be able to grow effectively as well. So having that sorted out, I think, is important. There's a hand over there at the back.
Thank you so much for that talk. I really enjoyed it a lot. My question is actually in two parts. And my name is Anuprita. I'm from DEV, interested in sustainable food systems research. So the first part relates to, if you could please share your thoughts, if you have any, from the other end of the food chain. So basically, have you gathered some information in a sense, like, how have people or the clients received the products in terms of, like, the dietary diversity, or any thoughts from the actual consumption aspect of the products? Okay.
Service sector. Service sector, and Green King pubs, for example. You'll get some of our products in there. So that's kind of where the product is currently ending up. But I feel that there might be something deeper in that question which I'm missing, other than where it's going. So
Yes, thank you so much. I was getting at, like, the very end client base, for example. Have you had I don't know, data in a sense, like, have people received the food products with, oh, this is more in terms of nutritional value, or what are their kinds of experiences, that kind of the business end?
Sort of what I refer to as professional consumers. So people who are in the business of taste testing, looking at weight, looking at delicacy, all those kind of things. And it's what you would expect if your seed goes to heaven. So if you've got a fantastic growing environment, and you really should have a fantastic product, and that's what we're getting. But there's a part of it which we haven't actually done the analysis yet. Benefits compared to a conventional plant that you get out in the field. And that's something which we want to do. We just haven't really had the bandwidth to do it properly yet. So we would imagine because if you've got a better tasting looking plant, you kind of assume that it's actually it's just nutritionally better at the same time.
Yes, thank you so much. The second was about the scale. I just wanted to really hear your thoughts in terms of, like, adapting the idea to different changing contexts. So possibly internationally in different developing countries, for example. Yeah, really. Thank you.
So what sometimes it's important to understand of, what type of sort of scale revolution you could have in terms of a vertical farm. So if you picked up every single farm around the world and put them on one location and made one super duper large farm, that's equivalent of all of North America, Central America, and South America combined. Now, theoretically speaking, if you wanted to give humans a really boring diet, not much variation at all, but just to feed them, and you took the M25 and you built in there a ridiculously large building with no roads, no gaps, no nothing, multiple levels high, that theoretically is enough space to feed about 8 billion people. So it's the multiple harvest with the height just start to change the dynamics. So we looked at what would it take to grow, 1 million tons of wheat, for example? And, you're roughly looking at, 600 hectares or something like that. It's quite significant in terms of what you could be doing.
Hi there. I have a question here. Well, I have the mic, so I'm going to start talking. Really interesting talk, really inspiring, in fact. I was quite interested in the slide you showed with the list of possible applications. I really get that, it has to be high value. You have to get that premium, but the consistency, the cleanliness of the environment strikes me as extremely well suited to pharma, to nutraceuticals, to cosmetics. And of course, that's potentially very high value. You could work with partners who have a lot of money to invest in research, et cetera, et cetera. I just wondered if you have any, and I don't know, it might be business sensitive, but have you any examples? Are you already doing this work, those first three?
But yes, we really want to. And, we know that tobacco plants, you can spike them to create adjuvants, for vaccines. There's lots of things which you could theoretically grow in our kind of environment. I think it would be fantastic if you guys, who will probably be getting more discussions with, these kinds of sort of nutraceutical, cosmetic type of organizations that we do, to have those conversations with them. And those, yet again, could be the basis of a whole bunch of new research which you guys do in collaboration with us and with those organizations as well. Because, if you can have a very clean, controlled environment and you have a product which you want to have clean and controlled, it's probably easier to do it with us than in a field, to put it mildly. So yeah, we'd be, absolutely delighted to have more discussions on those lines.
Okay, we have time for 2 more brief questions.
Thank you. I'm Catherine Coventry. I'm in engineering. It's sort of going back to this lady's question here, because vertical farming came out of 2010 with Dickinson Despommier. And he was looking at the growth of farms in megacities. And I'm just wondering, a lot of the farms that have sprung up, especially in the UK, are situated in rural areas. And I'm just wondering if you see the wider ambition that Despommier had in 2010 for, limiting transportation of goods, etc., being realised at all in the next 20 years.
I think it's a really good question. And there was a big move for city farming, localized farming, and all that kind of stuff. The key thing about vertical farming is energy cost. All about energy cost. Everything like, yes, but energy cost. Yeah, but energy cost. You have to solve for energy cost. And energy cost is code for solar, wind, and batteries. That's what it means. And so if you want to have low cost electricity, you can't be in a city. Can't. Because there are 2 types of electricity, the pricing in your electricity. There's the price for the underlying commodity product, the brown price, as it's historically called, even though, of course, now we have renewables, it's really aren't brown at all, but still called the brown price. And then you have the grid-related costs on top of that. And in the UK, the grid costs are now higher than the underlying price of the electricity. So if you are in a city and you are receiving electricity, even if all that electricity is green, you're still paying more money because you're actually paying the grid connection charge. But if you have your own solar farm and wind farm and battery system, you're not paying the grid cost. So not only is your brown price cheaper than the brown price, but you're not having any grid costs associated with that as well, which means that the price that you're paying for electricity will be a third, 25% of what you'd be paying if you're getting directly from the grid. So that is the reason why city-based systems can't compete on price, because their electricity cost is simply too high. Now, there's another question, which is distribution. You know, it's like, well, if you're moving things around. And if you think about distribution, you've got, you know, livestock. Livestock generally have significant restrictions in terms of where they can. Isn't really that worried about whether it has to travel 4 hours or 6 hours or 8 hours. You know, it's kind of okay. And the UK is a really tiny place. So there's not really that many places in the UK in terms of population density, which are more than 4 or 5 hours from where you need to be. And so the transport costs are significantly lower. And we did a carbon study, and we compared ourselves to UK farms, product grown in UK soil versus product which is grown in Southern Europe versus air freighted. And you know, we are several hundred times better than a UK farm in terms of carbon footprint. And we are 1,776 times more efficient than air freighting products from places like Ethiopia and Kenya, where a lot of our, you know, so a lot of the short leafy green things which we eat here come